Continuing chapter on behavior. Caption, we don't know exactly who he is, Captain. A disgruntled worker, we figure. Bees, of course. A bee with a bomb attached to where the nest is hanging. Although that really looks like a wasp nest rather than a bee's nest. But, you know, whatever makes the joke work. And it brings us to aggression. Aggression is an action or a threat that is delivered to resolve some sort of conflict. It could be a conflict within a group. It could be a conflict with a member of another species. It could be related to this or not. Agonistic behavior is honest-to-goodness fighting. And again, it could be fighting within the species. It could be fighting with another species. The little lizards that are in the lab, the little anoles. I'm assuming that this is a behavior that only happens when they're confined, but I've noticed over the years of having them for many, many years, they don't live that long, but you get new ones. And typically there's a group, and they're all brown but one. One of them's green. They can change from green to brown. And the green one is kind of acknowledged as they can sit wherever they want. You know, they're kind of the top of the pyramid. When one of the other ones decides to challenge, they will get in the line of sight of the green one and turn green themselves. And the former leader, dewlap will come out. It's a little flap that turns red, and they'll bob at the challenger. The challenger, dewlap will come out, they'll bob back. Then the leader will move next to the challenger and bob a little bit more excitedly. Now here's where you get escalation, and at any point the challenger may decide to back down. But it does go through several stages well before it gets to the fight. It's a threat rather than an agonistic behavior. Is that the leader will turn sideways, and you'll see a ridge develop along their back. They're actually making themselves a little flatter, and they look a little bit bigger from the side, as if to go, look how big I am. Do you really want to follow through on this? And then they will get up next to the challenger and open their mouths, kind of up next to their shoulders. And if the challenger has not backed off, then the leader will clamp onto the back of the challenger. The challenger will try to evade him and clamp onto and that's, they struggle with these, they bite each other on the back of the neck. Because I've lost some through infections that they get from these types of behaviors. But it very rarely gets to that point. It's usually just the bobbing. And one of the weird things that I've noticed is that sometimes early on, the challenger will back down. Well, what does that mean? Well, they move out of from where the leader can see them. If they stay where the leader can see them, they better stop being green. They better turn brown, because that's a way to de-escalate the situation. But if they get out of the line of sight, you can almost see them like crouching down the bottom of the tank, staying green, as if, you can't see me, but I'm still green. It's, you know, see, this is what happens. Interpretation of what's going on in another brain. That's almost certainly not what's happening, but it kind of looks like what's happening. A lot of times, you've got weapons. Typically, weapons that are used within a species, like the males fighting with each other, are not lethal. Bighorn sheep beating on each other. White-tailed deer getting their antlers kind of entangled, is that they're not supposed to get entangled, so they lock together. That's a way that can get lethal. but it tends to keep them from actually getting and impaling each other. Elephants, a little tricky, is that we talked about this in the evolution lab, is that elephant tusks, because they are used for digging water during the dry period, they actually are potentially lethal. If they're head to head with each other and they're wrestling and one of them slips, they can get a pretty decent tusk in the side and that can kill them. So, but under typical circumstances, like when elephants that adapted to more water reliable areas, those tusks curled up. They became less lethal, or curled out, as you see in the mastodons, curled up as you see in the mammoths. Weapons that are used against other species, much more likely to be lethal. Stings, venom, poisons of other sorts, is that you don't really care if a member of another species dies, is that a member of your own species, you try to kind of keep them alive to work another day. So non-lethal within species, lethal between species, typically. The bobbing and the dewlap and the whole procedure that I described is a ritualized procedure, a ritualized behavior. They go through these steps in a challenge. And ritualized behaviors can work a number of different ways in terms of aggression. Is that when you're an orb weaver spider, the female's up in the web, a male needs to get to her. If he climbs on that web, she's going to detect his presence, and she's, her response is to attack things in the web and eat them. What the males do is that they grab a couple of the support strings and they shake them a particular way. Ritualized behavior basically says to the female, stand down, I'm going to come up, we're going to hopefully make babies. There actually is a species of predatory beetle that can shake the web in the right pattern, and the female allows them to come up, and then they kill and eat the female. So ritualized behaviors can be taken advantage of sometimes by other species. But any kind of behavior that kind of falls into a fixed action pattern that that relates to aggression one way or another is, and there's ritualized behavior for other things as well. When I described the baboons, one female was higher in the social structure, in the social order, in what they sometimes call the pecking order, because it was first worked out with chickens, strangely enough. And the higher up in the stratum you are, the more rights you have over the larger group beneath you. Is that female had every right to beat the crap out of the lesser female and not expect retribution. In fact, not really expect the other female to fight back. It's in baboons often associated with being bigger and stronger and older and more experienced, so the younger ones, the smaller ones, don't want to fight back because if it escalates, they're going to be in a lot of trouble. But in some cases, it's just a matter of stand down. If you have multiple pets in a house, you see this kind of structure happen. Sometimes it's not the biggest and the strongest. Sometimes it's just the most aggressive, the one that, there's all sorts of releasers that get the other ones to kind of back off. But humans have this as well, obviously. Nope. Another type of behavior involves territory, an area that an individual or a group kind of lays claim to. It can be very strict. It can have very strict boundaries, and some rivals come into those boundaries, and then there's going to be conflict. That's why it's associated with aggression. In some cases, the territory may kind of move around with the group, where we're settled here, something gets a little bit too close, we're going after it. We move away, we don't care about where we just were. Very often it has to do with, it's benefits and costs. Is that the cost is You have to defend the territory. The benefit is, what are you getting out of it? Is food scarce enough that you can't afford to have another group coming in and using food in the same place that you are? Is a lot of animals that eat grass and live in a grassland, they're not territorial. They don't really care. There's plenty of grass for everybody. And animals that are like using fruits or things that are in limited supply or seasonal or whatever, then they may very much not want rival groups coming in and eating their food because it means less food for the group. Territoriality can be mating restrictions, where a bull elephant in charge of a herd of elephants doesn't want another male within a certain threshold of space. It's that the herd has territoriality, that they're protecting more for his benefit than for food benefit, although there's a certain amount of food benefit with elephants. Sometimes this is named in terms of home ranges. With bears, is that bears kind of cover a large area, and another bear may cover an area that overlaps like a Venn diagram. But because it's a very large home range, they very rarely are going to run into one another. And when they do run into one another, there's a really good chance that they both believe they're in their own territories, and there may be conflicts based on that. Whereas usually they're not going to come in contact with one another. I saw another Far Side recently where two turkeys at home, one of them's reading the newspaper, and rise in axe murders recently, turkeys. This one is that a chicken has somehow made a grabbing and chopping, basically a decapitation thing, and he's thinking, bottom of the pecking order, eh? Oh, I don't think so. Like that he's got a screwdriver and another screwdriver, and he's got a wrench. He's an industrious chicken. Oh, the box of dead flies, Ramon gave them to me Saturday night during his courtship display. Of course, they were already sucked dry. Like when you give somebody a box of chocolates and you've already picked through and taken the good ones. Enter between species. Predator-prey. In some cases, this involves displays. Is that you don't want to mess with me. You're going to regret it. It could be that I'm poisonous and I'm going to bite you or sting you, and you're going to come out of it not really getting what you want. And there was a mystery, somebody in my alma mater, is that painted turtles have these, very often the defensive displays are very contrasty. So even predators that don't see color, that will make the potential prey stand out in the background. And the message basically is, I want to stand out, I want you to know I'm here, I want you to stay the hell away from me. And painted turtles have these very contrasty markings on their heads, but they don't produce any kind of venom. And so researcher that in my old alma mater found out that hatchlings, when they're hatched, is that they are preyed upon by very large fish like lake bass and such. But when a bass grabs a baby painted turtle, it plants its back feet across the mouth, the pharynx, the throat opening, and takes its front feet and claws the hell out of their gills until they spit it back out. And then they don't go after baby painted turtles anymore. This is often a learned behavior where it may take an experience with a bad experience with a potential prey animal, And sometimes that prey animal doesn't survive the encounter. But it does tend to teach. Some animals naturally avoid things that are very contrasty. Some of them have to learn to avoid things that are very contrasty. They may learn to avoid specific animals that are contrasty, or just generally black and white, black and yellow, black and orange, things that just appear very contrasty. Whether it's a bee or a coral snake or a skunk, right? You're going to regret going after the skunk, or a porcupine. Sometimes the display works with a sense that the animal that's doing the display doesn't even have a rattlesnake, doesn't hear its own rattle. It's warning potential prey animals or predators that can hear to stay away from it. Is it the rattlesnake itself needs to be pretty good camouflage because it needs to hide so that when its prey comes by, they don't see it. So they use the sound to, if something big comes into the area, sound to go, no, don't come over here, don't step on me, you're going to regret it. We've talked about this before. As a parasite or a pathogen, what sort of adaptations do you see over time? Is that you may find that the host species develops ways to evade the potential pathogen or parasite. And then the pathogen or parasite kind of has to adapt in order to get around that evasion. Is you get this kind of back and forth, this coevolution that happens, both in predator-prey relationships and in parasite-host relationships. And we've talked before about symbiosis, where both of the two participants are benefiting in some way. This follows up on the rattlesnake and the contrast and a bunch of other stuff. Communication. How do animals communicate with each other? Well, they need to use a sense that the other animal can pick up. A rattlesnake is using a sense that it doesn't have, but its potential predators can hear the warning that it's giving them. Some animals communicate through scent because that's their primary mode of working with the world. Some of them, like contrasty animals, use sight. And they may not even see all that well. Millipedes don't really see very well, but they're very contrasty. They're, they spit cyanide at you if you grab them. We talked about pheromones before. Some of the communication gets pretty complex. The waggle dance that bees do. A bee finds a potential source of food that it can share with the hive. It brings back what it can, and then it gets on the vertical side of the hive and does a waggle dance. And the angle that it orients according to gravity, straight up and down versus an angle, is a message to the other bees that crowd around and touch it, because it's dark in there. The angle tells them, okay, when you leave the hive, orient, according to the sun, orient at this angle. And the waggle, the shake of their butt that they do, which the other ones can actually hear, and also pick up through the vibrations, it's a pretty tight place, tells them, okay, how far do you need to go before you start looking for this food? May have mentioned this before. Somebody got the bright idea of putting a potential food source in a, there was a pond on the territory of these bees, and they put a food container in a boat and pushed the boat away from shore. And then what happens is, if you have these accessible hives, you can actually mark the bees either out at the food source or before they leave. But what they actually found was, the farther out into the pond the food source was, the fewer bees that came in contact with the waggle dance would leave, which suggests they thought that the waggle dance was kind of a stereotype behavior. That you kind of programmed them the angle and programmed them the distance, and that's where they went and searched. But it actually turns out that a significant number of the bees in the hive know where they're going. And when the message was, go out into the middle of the pond and look for food, a significant number of them would go, no, I'm not doing that. It's the middle of the pond. There's no food out there. And they wouldn't even leave the hive. So, and at the very end here, I'll talk about, are there intelligent aliens out there sending out communications into the ether? What are you going to look for? Is that the assumption has been always that the universal language is based on math, because math is how how physics and cosmology and everything kind of follows particular patterns, and that if you can show a recognizable pattern to an intelligent alien, they would recognize the pattern because it's something they would have already figured out, or they wouldn't be communicating in the first place. But then it's a matter of, are you using a communication mode that they would be using? Is that, we look for radio broadcasts. We're not using radio broadcasts that much anymore. And as we advance, is that we may be using different frequencies. So picking up radio broadcasts may not be an effective way of picking up other messages. Basically what they're doing is they're looking for repetitive patterns that suggest a non-natural source. And there've been a couple of they've picked up some, but they seem to be, they don't continue. And so they're not repeatable, and therefore maybe it was just a coincidental pattern. Okay, that's it for this semester. That's it for this chapter. Bye.